Hello everyone. We have studied in the four pillars of theory of computation. But what is the purpose of these pillars, alphabet, strings, languages? So I can tell you in simple words. Let us consider any programming language like C, Java, or Python. In all the languages, whenever you write a program, you can call the particular line of codes, call it as a program. So you write a program in any language. But if you consider the theory of computation subject, this program is nothing but the collection of strings. Collection of strings. Okay. So program is generally referred in terms of their programming languages. But if you consider the program in a particular this subject, then this program is nothing but a collection of strings, and it is all the programs are comes under the valid. So valid programs. Okay. So if you ask me that what is the total number of valid programs available in any programming languages, then my answer is infinite. There are infinite valid programs available in any programming languages. Okay. So this is the one part. You can think that the application of theory of computation is used in any programming languages. And the second one is, if I give you some language, let's say language is Alice. For example, language L1 is AA, AB, BB and BA. So this language contains 4 strings. Okay. And if I ask, find out whether this string W, which is AAA, belong to this language or not. So can you answer? You can definitely answer this question. You can say that this particular string is not belong to language L1. But what happens if language is infinite? Let's say language L2 starts with A, AB, ABB, ABA, and so on. And then if I ask the string W, which is, let's say, BA, BB, A, is belong to this language L2 or not, then can you answer? You cannot say that this particular string is belong to the language or not. So for such problem, if the language is infinite and if I given some strings and ask you that whether this particular string is belong to the language or not, so for this problem we have to represent a machine, or we have to form a machine which can answer this question. Okay. So how can we form a simple machine which can answer the question where our language is infinite? For this purpose, we need a finite representation. Okay. Finite representation of what? Finite representation of a language. So you have given a language, you can construct a finite representation of that language, and I will give you some strings. Okay. Then using this finite representation and seeing this particular string, you can definitely answer that whether this string belongs to the language or whether this string does not belong to the language. Okay. This finite representation is called finite automata. Finite automata. Actually, this finite automata word comes from the word automaton. Automaton. So automaton is a plural word and automata is a singular word, and it comes from automaton. So automaton is a simple machine or representation in this subject which can definitely answer this question whether a string is belong to the language or not. And if you understand the finite automata very well, then you can answer any question in GATE. Okay, so finite automata is the most important topic in theory of computation. So let's start with the finite automata. Finite automata is classified into two types. So you know that it is a representation which is used to say whether a string belongs to a language or not. If I classify the finite automata, I found out it is divided into two categories. One is finite automata. Let's abbreviate this finite automata as FA. Okay, so in short form, I call it as FA, finite automata with output. Okay, and finite automata without output. Further, finite automata with output is classified in two categories. First one is Mealy machine and second one is Moore machine. The next one is finite automata without output. It is classified into three categories. One is deterministic finite automata, okay. Next one is non-deterministic finite automata, and the last one is non-deterministic finite automata, epsilon non-deterministic finite automata. Okay, so NDFA and epsilon NDFA is very much different. I mean to say that here I can use the epsilon symbol, but here I cannot use the epsilon symbol. Okay, so first we shall look out the finite automata without output, where we discuss deterministic finite automata in detail. Then after that we will start non-deterministic finite automata, and finally we cover epsilon NDFA. Finite automata without output, after we shall look at finite automata with output. Okay, so in the next video we will discuss deterministic finite automata.